Hello, dear friends. Today we will going to discuss the complex number. So before we start complex number, first we ask the square of any number is positive. Like 2 square is equals to 4. Here the number means the real number. Minus 2 whole square is equals to also 4, because minus 2 into minus 2 is equals to 4. Minus root 3 whole square is equals to 3. So square of any real number is positive. Now, when we ask for the solution or roots of the following equation, what happens? First equation is x square minus 1 is equal to 0. So, x square minus 1 equals to 0. We can break x square minus 1 into two linear factors, and from them we get x minus 1 is equal to 0 or x plus 1 is equals to 0. And therefore, we get x is equals to 1 from this equation and x is equals to minus 1. And both are real numbers. So these are the real solutions. Are 1 and minus 1. Next we want to solve x square plus 1 is equal to 0. X square plus 1 is equals to 0. So if you write x square is equals to, then we got minus 1. But we know the square of any real number is positive. So in this case it is coming minus 1, and that means it has no solution. So x has no value, for which x square plus 1 becomes 0. So when we try to solve this equation, we have failed to find the solution. But square of real number cannot be negative, because square of real number cannot be negative. So in real number system, we cannot solve x square plus 1 is equal to 0. But as our intention is to solve every polynomial equations, so we extend the real number system to a large number system. To a large number system. And this large number system is called complex number system. And in complex number system, we are able to solve any equations like ax square plus bx plus c is equals to 0, where the discriminant d may be positive, may be equals to 0 or less than 0. Euler was the first mathematician who introduced the symbol iota for root over minus 1 with property that root over minus 1 whole square is equals to I square is equals to minus 1. So thus I is a symbol used for root over minus 1 so that minus I square is equals to I square is equal to minus 1. Similarly, we can write root over minus 4 is equals to root 4 into root I, that is equal to 2I. Root over 3 minus 3 equals to root 3 into root minus 1, that is root 3I. This way, we first taking the negative of a square number and introduce I. Now we can solve x square plus 1. So here x square is equals to minus 1. So this implies x is equals to plus minus root over minus 1 is equals to plus minus I. So we are getting two solutions for x. One is plus I, another is minus I. Now definition of a complex number. A number of the form x plus iy, where x and y are real numbers, is called a complex number, and the set of complex number is denoted by C, capital C. So a plus ib, if it is a complex number, belongs to C, where you can define the set C is equals to all numbers in the form Cartesian product form a comma b such that z, which is a complex number, and z is equals to a plus ib, where z belongs to C and a and b both belongs to R. Example, 2 plus 3i. It is in the form a plus ib. Here a is equals to 2 and b is equals to 3. Both are real numbers. 2 minus I. It is also in the form a plus ib, where a is equals to 2 and b is equals to minus 1. So any complex number is in the form a plus ib. Here there are two parts of z. The first part is called real z, and second part, this is imaginary z. In the next session, we'll discuss about the operations on complex number. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.